Welcome back. All right, today we're going to go over a couple examples from the 10.2 and 10.3 circle geometry assignment. So we're going to start off with number 8 from 10.2. It says the radius of the circle is 11.1. The radius CM is perpendicular to the chord LK, and MQ measures 3.4. So we're trying to find some lengths here. So what I'm going to do is just redraw this circle and fill out some lengths. All right, so it looks something like that. So it says the radius CM is perpendicular. So because it's perpendicular, we know this is 90 degrees. Okay? And it says the radius is 11.1 centimeters. So the temptation is to label this entire length as 11.1, but that actually won't help us that much or at all. So what we have to do is we're actually going to draw another radius here, because remember this was the center of the circle. And we're going to label this one as 11.1 centimeters. Okay. MQ measures 3.4, so we know this is 3.4. That also doesn't help us too much, but we do know the entire thing is 11. So to find this missing side here, we're going to go 11.1 minus 3.4, and I get 7.7. So a little bit of subtraction there to give us this missing length. And then it says, what is the length of chord LK? So it actually is asking us to find this entire chord, but we can't do that in one step. What we're going to do is we're going to find this side, and then because it was perpendicularly bisected, we know that they're the same, so eventually we're going to double it. Okay, so for all these questions, almost all these questions, we want to look for this. We want to add ourselves a radius, notice where the right angle is, and then we're going to use a squared plus b squared is c squared, or Pythagorean theorem. Okay, so I'm going to label this as A, B, C. Now these letters have nothing to do with the LMQ from the question. This is just how the formula is written, remember. So A squared plus B squared is C squared. So we have 7.7 squared plus B squared is 11.1 squared. Remember, this C is the most important one. It has to be the longest side across from the right angle. Okay, so then we'll do some math, bring that to the other side. So B squared is 11.1 squared minus 7.7 squared. So that equals 123.2 minus 59.3. And then I get B squared equals 63.92. Square root both sides, and B is equal to 7.99, so we'll say approximately 8 centimeters. Okay, so we found this is 8, and then the question, like I said, actually asks for LK, so all the way from L over to K, so we're going to times it by 2. So 8 times 2 gives us 16, so the distance LK is 16 centimeters. Just make sure you have your units in there. I haven't been writing them in the question because it's a little tough to write with this method, but just make sure your final answer has some units. Okay, so that's kind of the steps we're going to try for these next couple questions, is finding a spot to draw an additional radius and then using Pythagorean to solve it. Okay, so let's do 9. We can do A and B here. Calculate the unknown length x. Okay, so again, we have a radius of 6. So for part A, we have a radius of 6. And so we can figure out that that missing side is 6 minus 3. Right, so this side here is also 6. And then we know that this x is going to be the same here. So what we have is essentially a triangle. Okay, we'll just draw a little bigger. So we have 6. Oops. We have 6. We have 6 minus 3. I said 6 before, I meant 3. So because this is also a radius, we subtract this 3, and we get 3 centimeters here. And then x is going to be the same as that side. And we know this is 90 degrees. Okay, so same idea. So right away, we can plug it in. A squared, so let's call this A, B, C. So 3 squared plus x squared equals 6 squared. And again, you can do this how you're used to doing it. I'm going to rearrange it. 6 squared minus 3 squared. 36 minus 9. 27. Square root it. And I get x is equal to 5.2. It actually doesn't give us a unit, so just 5.2 is good enough. Okay, so similarly, we'll do part B over here. So they try and confuse us because they give you sort of everything but the triangle dimensions, but we actually know the triangle dimensions based on this information. So let's draw ourselves another triangle here. And this is what we're trying to figure out. So I've just redrawn this triangle. Okay, so right now we know the radius is 10, right? Because this goes all the way across. So that means this is also 10. Okay, let's see what else we know here. The 9 centimeters, right? Because it's perpendicular and it goes to the center. We know it's bisected, so this is 9. That means this has to be 9. And so they actually don't care about any of these dimensions, they care about this one. So we know that that plus this gives us the radius. So we're going to find this side. I'm going to call this B. And we're going to find B. And then eventually subtract it from the radius to get x. Okay? So let's see what we have here. So we have 10. Sorry, b squared plus 9 squared equals 10 squared. So b squared equals 100 minus 81. B squared equals 19. We're going to square root, and we're going to get b is equal to 4.35. Now we're so close. We found b, which is this side here. We need to find x. So remember, this is going to make up the radius. So x is going to equal 10 minus 4.35. And I get 5.65. That's my answer. So they try and trick you by labeling everything but the triangle, but in fact you can relatively easily figure out which sides you know and work from there. Let's do one more from 10.2. We're going to do number 10 here. So again, they're trying to give us some different way of looking at this question. So we're going to draw it sort of how we're used to it. So, and there we go. Here's our water pipe as we look at it. The circular cross-section of a water pipe contains some water in the bottom. The horizontal distance across the surface of the water is 34 centimeters. So this distance across the water is 34. Okay. The inner diameter of the pipe is 50 centimeters. So the diameter of this is going to be 50. So we don't usually care about diameters too much, but what that tells us is that the radius is 25, right? That's the important thing we got from that. What is the maximum depth of the water? So we're trying to make this look like the other questions. So we're going to draw ourselves in. Here's the center of the circle. And let's see, it says it's 34 centimeters, so to make a triangle it's useful, because it's 34, because we know they're both the same, I'm going to label each side as 17, right? This whole distance is 34, so we're going to cut it in half, basically, and get 17. So let's see what else we know. We know the radius is 25, so like I said, we're going to always try and draw ourselves another radius. That's 25. Now we're so close. We're trying to find the depth of the water. So let's call it D, this distance here. So similar to the last question, before we can do that, we're going to find X, and then we're going to subtract it from the radius to get D. Okay, so we use Pythagorean, same idea. So we have x squared plus 17 squared is 25 squared. X squared equals 25 squared minus 17 squared. Solve that out. 625 minus 289. And I get 336 for x squared. We'll square root them. And x is equal to 18.3. Okay, so this is 18.3. So to find the depth of the water, because this is also a radius, right, from the center to the bottom, so we're going to minus 18.3 from 25. Oops. So 25 minus 18.3, and I get the depth of the water is going to be 6.7 centimeters. Okay, so fairly straightforward. So we take what they give us. This time they tried to fool us with the diameter, but we can easily cut it in half to find the radius. They give us the full 34, but usually we're going to need to cut that in half and use the bisector and make ourselves a triangle, and we're good to go. All right, let's move on to a couple examples from 10.3, which deals with tangents. So I'm going to talk you through this one as opposed to drawing it most of the time, just because it's a little bit easier to do it that way. So we have this diagram. AB is a tangent to the circle. So remember, a tangent means that it touches the circle just at one point. Okay, and remember the properties of a tangent is that the point of tangency right here, so D, to the center is going to give you 90 degrees. Okay, that's basically the only property that we need to remember too much. Okay, so we're going to explain the reasoning of each of these things. So A, what is the measure of BDC? Well, I just said it has to be 90. So BDC has to be 90, and I'm going to say it's the point of tangency. And you can look up exactly how it's worded in the textbook, but that's the most important thing. So if you want to draw that in or write it, go for it, but we know that that's 90. What is the measure of central angle DCE? Okay, well, let's look. DCE. So before we can do that, we have to find the angle that they don't ask for, this one. Okay, so remember, all angles in a triangle, regardless of the shape of the triangle, have to add up to 180. Okay, so one of them 60, the other one we found was 90. So our goal in part B is to find DCE, but before we do that, we're going to find basically DCB. Okay, so that angle is 180 minus 90 minus 60 is 30 degrees. So this little angle here is 30 degrees. Now, remember, angles in a straight line, so if we have a straight line and then we cut it in half, they have to add up to 180 as well. So now we can find that. So 180 minus 30 equals 150. So angle DCE is 150 degrees. That's our answer for part B. Okay, so I use my knowledge of triangles to figure out this angle, and then I know that because it's a straight line here, it also has to add up to 180. Hopefully that makes sense. I apologize that it's a little squishy in there. All right, part C. What type of triangle is a triangle CDE? So triangle CDE, let's look at it. Well, it has a radius here, has a radius here, so it has to be isosceles. Because, and you can explain basically because two sides are the same, right? D, Let's see what D says. What is the measure of DEC? Okay, so we found the first angle in the triangle was 150. And then we know because it's isosceles, both these other ones have to be the same. So we're going to go 180 minus 150 to start off. And I get 30. And because they're the same, and we only have 30 degrees to split, we have to divide this by 2. And so I get 15 degrees. Okay, so this unit is less a squared plus b squared and more kind of playing around with angles. So we have to remember basically two things. That triangles add up to 180, and that straight lines, if you cut them in half or cut them anywhere, both sides have to add up to 180 as well. Okay, so let's keep that in mind. Let's look at a couple more. Number 5, it says in the diagram, AB is tangent to the circle at point B. BD is the diameter, AB equals 6, AD equals 10, and triangle BCE is an equilateral triangle, so all the sides are the same. So let's go through and see what we can figure out here. Part A. What is the length of diameter BD? Okay, so because it's tangent at point B, we know it's 90 degrees. That's how we prove that. Okay, so in this case, we do have a triangle that we are going to solve. Okay, so I'm just going to zoom in on this a little bit. So we have 6, 10, and then BD, right? This diameter. So we're going to use our Pythagorean. So we're going to go 10 squared minus 6 squared plus BD squared. 100 minus 36. 64 square root. So dB or BD is 8 meters. Right, so we solve that with Pythagorean. Okay. Done part A. Part B. What is the length of chord BE? Okay, so we have to think here for a second. So if we look at our diagram, we know that this entire diameter is 8. We know that this is a radius, right? Because we cut it in half. So, and we know that all three of these sides are the same. So this would be 4. All three sides of this triangle are 4 meters long. So the chord BE, there you go, has to be 4. You can explain it that way. So because it's the radius and because it's equilateral, they're all equal to 4. Okay, let's move on. Part C. What is the measure of the inscribed angle BED? Okay, it's been a while since we've done that, so let's look. BED. So this angle here. Well, that actually also has to be 90, right? Because we have the central angle, that's 180, and then the inscribed angle is going to be half of that. So angle BED has to be 90 degrees. Now, I want to just be very clear. This entire angle is 90. Okay, so like this shape here gives you 90. And I realize that it's split up, but it's asking for that. And I think it's going to ask us for one more length here. So it says, what is the length of chord DE to the nearest meter? So now we have another triangle that we have to sort of use to solve this. Okay, so let's fill in what we know here. So BE, how long was that? BE was 4. BD was 8, and then it's asking for DE, this one. We're trying to find this length here. Okay, so same thing. That's why it got us to realize that would be 90, and now we can solve this in part D. So 4 squared plus DE squared, if that makes sense. You can write it like that, or you can give it another letter. That's fine. So I get DE equals 64 minus 16 gives me 48. We're going to square root that. And so DE gives me 6.9 to the nearest meter. No, to the nearest meter, I guess we can round it to 7. Okay, so there we go. So basically anytime we see that there was 90 degrees, we had to solve something. Otherwise, just kind of playing around with angles. Alright, last one for this video. Number 6. FG is tangent to the circle at point G. Okay, GH is a diameter, tells me that. It says CJ is 5 millimeters. We see that's another little equilateral triangle. So they're all going to be 5. FG is 7. Okay, and again, it tells me it's an equilateral triangle. So what's the length of the diameter? Okay, well, let's see. Well, the radius is 5, right? So the diameter has to be twice the radius. So 10 millimeters. Done. Okay, is GHJ a right triangle? Let's see. GHJ. Do you see that? Is it a right triangle? Yes, right? Because GH is 180. And that is a central angle. And GJH, or GHJ, would be the inscribed angle, which is going to be half. Okay, so the answer is yes, 90, and you can explain how it's an inscribed angle. Okay, put a few more words in that, but that's kind of the reasoning why. Part C, what is the length of chord HJ? Explain your reasoning. Okay, well, let's see. HJ, so we're trying to find this guy here. Well, we know that side is 90, so, and we know the diameter is 10, so basically we have another triangle here, right? Let's draw it better. Oops. Okay, so this is G, J, H. Okay, so GH is the diameter, which is 10. GJ is the same as 5, right? Because it's equilateral. And so we're trying to find HJ. So a little bit of Pythagorean again. 10 squared minus 5 squared equals HJ squared. So I'm running a room here, so we solve it. We get 75 is HJ squared. We're going to square root it. And then HJ is 8.7 millimeters. So solve that, show all the steps. But that's a little quick version there. Okay, and again, that was because this was 90 degrees. We knew this side. We knew the radius, so we could figure out the diameter. Pythagorean. Done. Okay, part D. What is the measure of angle FGH? FGH be up here. Well, that would be 90 degrees because it's the point of tangency. Okay. E, what is the length of FH? So now I have to find this length. So again, we need to make another triangle here. Oops. Having fun making triangles today. So let's see what we know here. We know this is 7 because they told us. We know the diameter was 10. We know it's 90 because point of tangency. And we're trying to find FH, so we're trying to find this length here. So that's actually the hypotenuse, right? So 7 squared plus 10 squared equals FH squared. 49 plus 100 So 149 square rooted, and I get FH is equal to 12.2 millimeters. Okay, so basically for 10.2, we're trying to find right triangles, solve them. And for 10.3, sometimes you have to do that, but it's more not necessarily about drawing an additional right triangle, but just sort of proving which angles are 90 and then solving it from there. If you do have any more questions, especially as you did the review, please don't hesitate to email me, and we're going to move on to the next chapter right away. Thanks, everybody.